G'day, I'm John, VK5DJ, and welcome to our site halfway between Millicent and Mount Gambier, where VK5RMG is located and all of the related bits and pieces. So enjoy your walk through as I describe the various components that make up the VK5RMG site. Okay, we're inside the shack. And we're starting over here with our power supply section. So starting with the top, we have our solar controller, and we can see we're currently reading 65.8 volts on the solar panels, and we're running at 5 amps into the battery. The little box there is our means of monitoring remotely, and from there we can see what voltage and what current is from the controller. Nick has excellent access to that. So as we proceed down, this is our distribution board and our battery isolator on the side. Now this is a new addition. Here is a method of ensuring that if the battery fails or it's flat for whatever reason, we're able to switch through to our battery charger. And we'll deal with that in a moment. But it uses diodes to do the switching and is a very recent addition. Further down the list, we have this device that detects when the battery voltage is low, and it's currently set for 11.8 volts, and when it reaches 11.8 volts, it turns on the battery charger down here, which provides AC power. This is for use in an emergency, and we don't anticipate this being switched on very often, but if there is an occasion where we've had not excessive use, but strong use of the system, then we are able to turn on the power and operate the gear from this power supply. When the volts are up to 12.8 volts, this device goes into a second mode, and the second mode says, I'm going to keep charging for a while, and then after 100 minutes, it turns it off. The various indicator lamps do different things. So that's the system. Then at the bottom, I'm not sure if it's showing up, is our lithium iron phosphate battery. This is a 200 amp hour unit, and we've found that over time that the lead acid cells were just not satisfactory, and the 200 amp hour lithium iron phosphate can be discharged quite significantly. With the lead acid, you really can't go below about 50% if you want long life, whereas these can go down to quite a low level and give us much more output from the same nominal amp average. So that's our power supply system here. On top we do have another little device which you can't see, and that's an AIS vessel tracking receiver. Each large boat and many yachts have a transmitter on board that reports their current position, and there's a receiver up there on 162 megs or thereabouts, and it's reported to the web via our internet connection. So that's our power supply section. Okay, we're now looking at the 2 metre and the links. VK5RMG is the centre of our network. The network extends up to Narracourt and Willaluka and across to Mount Benson and also to Mount Richmond in Victoria. So at the very top is our distribution board. Each of these sections, cabinets, have a separate distribution system, suitably labelled so we know what we turn off or turn on. And the first, I think I'll go to the bottom here for starters. This is the 2 metre repeater. It's a PRF 1820. It's a very nice commercial unit, and it's served us well for many, many years. It's up to 50 watts output. We have it set for about 25 watts, and that seems to meet our needs very well. And that is our main repeater for this area. When we move up a bit, we come to the control section. The controller is here. Touching it wakes it up, and this tells us the state of the nation. Currently the repeater is off, link 1 transmitter is off, and link 2 transmitter is off, and I'll expand on that in a moment. It tells us that all receivers are waiting and the CT/CSS is off and audio is somewhere below -20 dBm. If I take our handheld and we fire up the handheld with the bluff, and you can see that the transmitter has fired up towards Narracourt, is fired up towards Mount Richmond, and it's fired up towards Mount Graham. And you'll see on the indicator down here, the repeater is on and it's timing. Link 1 transmitter's on, link 2 transmitter's on, the repeater receiver is on, link 1 and link 2 are inhibited in their receiver, and the CT/CSS is off. So that's that section, that's the 2 metre section. Here in this area we have a second controller because the main controller supports only 2 levels and the 2 links, so it's had to be split with a sub-controller so that the Narracourt link is split into Mount Richmond and Mount Graham via this sub-controller. So these are UHF links. Richmond 449.875, Mount Graham 430.475. So that's the main 2 metre device. Down the bottom we have the cavities. There are 4 cavities in each section. We live in a very busy RF environment. The first 3 in each have notches, and the output finally goes into bandpass filters so that we meet requirements of the ACMA. All repeaters, in fact all devices on these sites, must have a bandpass filter to minimise the effect of interference with other services. So that's our 2 metre and its link system. Okay, this is our 3rd cabinet, and our 3rd cabinet will begin with our power distribution section at the top, and below that are the cavity filters for the UHF links. These are required for legal reasons, as earlier explained, and they provide reasonable bandpass at the 400 megs that they operate on. Below that is our C4FM unit. It's a Yaesu DR2X, and currently we have a display. These displays, they all time out to save the devices, and the unit operates on 439.825 and receives on 434.825. It's a very nice unit. It's running about 20 watts or thereabouts, and it powers into single antennas on the tower. Below the C4FM unit is the cavity for the transmitter on the C4FM unit, again to meet requirements as a bandpass. And although you can't see it, over there we have a filter to try and cut out the commercial digital transmitters that move in frequency and do all sorts of strange things and give us considerable problems with raspy noises. So combined with the CT/CSS and the filter, we get acceptable performance. Next down the line, in this area here, we have our Echolink transmitter. Our Echolink transmitter has been put through into our 2 metre system so that the computer here, which is a small computer, decodes from via our modem and is then linked into 2 metres. Below that is our VK5RMG APRS transmitter, and it's in abeyance. We're currently waiting for the license to come through, but that's all ready to go. So that's our second cabinet, primarily the UHF and our little auxiliary devices. So that's the three cabinets. Hope you found that very interesting. Right, we're at the back of the units now, and first of all down here you'll see our modem router, and you'll see that it's currently in operation, just sitting there talking to itself for the moment. Up here is that filter I spoke about when I was out the front, and that's for 160 megs to try to keep that out of our 2 metre unit. It's a bandpass filter and seems to perform quite well with quite an attenuation at our 2 metre frequencies. Over here are our cavities, and our 6 cavities, actually is 8 cavities, 3 plus 3 with notches, and these two as bandpass, again to meet regulations for the transmitter here and for the receiver. Another effort to try to keep out the 160 megs that is very dominant here at this site. On the back of the other units you'll see the necessary connections and the relays that are needed in the UHF links because they're simplex links. Something we haven't seen is towards the front of the unit we have a camera so that we can remotely have a look at the site and to identify if all the lights seem to be flashing as they should be. In addition, we're able to control the whole site via remote control with DTMF signals. So there you go, that's our VK5RMG site.